Welcome everybody. This is going to be our Algebra 2 topic of rational functions, simplifying rational expressions. This will be the first lesson of a number of lessons on rational expressions and rational functions and all. And so we're going to be discussing first off simplifying, and then we'll move on to some of the other things. So this is our first lesson. Hopefully it was helpful to you guys. So the first thing I want to do is simplify the following fractions, which really are rational expressions, are just fractions. So we're going to take our numerator and denominator and simplify what we can. So the first question is going to be 10ab over 5a squared. Well, one of the things that we want to do is kind of break them up into the same terms that we have here. So for example, 10 times a times b over 5 times a squared can be written as 10 over 5 times a over a squared times b over 1. And because everything is multiplying, we can, kind of break them up into these fractions that are multiplying each other. We know that to multiply fractions, you multiply numerator, numerator, and denominator with denominator. So we can kind of work backwards in this case. Well, we can now simplify our numbers with numbers. So we see here in this case, the 10 and the 5 can be both divided by 5. So 5 divided by 5 is 1, and 10 divided by 5 is 2. So we get 2 over 1. Now, this a is really a to the first power. And so a over a squared, this divides out to 1. We divide this a squared by a, we get left with a. So we're left with 1 over a. Just want to clean up that little dot there. Okay. All right, and then finally b over 1. And so in this case, when we multiply fractions, you multiply numerator with numerator. So 2 times 1 times b equals 2b. And 1 times a times 1 is a. So we're left with 2b over a. And so we can, in this case, break up our numerator into its kind of component factors, and our denominator by component factors, kind of group those factors together with numerator and denominator and simplify. Our number 2 question is b to the 4th times p squared over b squared times p squared. Very much the same way, we're going to group the b's together. So I have b to the 4th over b squared times p squared over p squared. And so we take a look here, b to the 4th over b squared, we can divide both of them by b squared. And so this becomes 1, and we're left with the numerator of just b squared. And p squared over p squared, that divides out to 1. Any number divided by itself except for 0 is equal to 1. Now we could multiply everything out. Do b times b times b times b, b times b times p over b times b times p times p, and just kind of divide each one out by itself. We kind of know in this case that first off, any number divided by itself is equal to 1, so p squared is 1. But b to the 4th over b squared, we can use our, in this case, our quotient rules for exponential, where when you divide two numbers same base, you keep the base and subtract the exponents. So we keep b, and then of course 4 minus 2 is just 2. So we're left with, just as our answer here, b squared over 1, which is b squared. Okay. So simplifying these single terms is usually pretty straightforward. Grouping together is not such a bad idea. However, we now get to our question number 3. And so question number 3 we see in this case is x squared plus 3x minus 28 over x minus 4. Now we cannot, unfortunately, cross out the 4 and the 28 and the x to the x. We can't do that though. You're saying, well, why can't you do that? Well, we know that 15 over 2 is equal to 7.5. You can use a calculator to double check this. But if I wrote 15 as 13 plus 2 over 2, and I'd say that, hey, I can divide out the 2's and get 1, that means I get 14. Well, which one is it? Now, keep in mind, when you enter the calculator, you have to enter it as parenthesis 13 plus 2. Close parenthesis, divide by 2. And you'll find that this is no good. You still, if you type in the calculator properly, you'll get 7.5. So the technique of crossing out or dividing out terms is not possible. That's not a good technique. It's incorrect, actually. But some of you might say, well, Mr. Gong, it's totally okay. It worked sometimes. No, we need something that works every single time. That's the thing. So what do we do? Well, in our first and second question, we had factors, meaning stuff that multiplies other. So, like, for example, 10ab was 10 times a times b. And 5a squared was 5 times a squared times 1. Well, the key thing for us in this problem is that we had to factor. So when you have a algebra expression divided by algebra expression, you can do log division. We've done log division before, but we want a factor in this case. So let's take a look at factors. All right. Our denominator is x minus 4. That's a factor by its own. So our numerator, we want to factor two numbers that multiply to 28, negative 28, and add to 3. We know that x squared is really x times x, so that's okay. Well, two numbers that multiply to negative 28 and add to positive 3 will be positive 7 and negative 4. Again, you have to go review your factoring. And so now we can divide out factors. So notice that x plus 7 and x minus 4 are multiplying each other. And the opposite of multiplying is dividing. So that allows us the opportunity to simplify the x minus 4 and x minus 4. We can only divide out factors. We can only divide out factors. So we get, in this case, as our answer, x plus 7. So, to simplify rational expressions, we sometimes need to factor the numerator and denominator and divide out the common factors. So the factoring is important for us. So review some of the lessons from before on how to factor trinomials, and in this case, using greatest common factor is also factoring out the difference in perfect squares, because those come up quite a bit. We definitely have to factor, especially when we have algebraic expressions here, right? So we have to simplify the following. Again, we want to factor. So we take a look, number 4. 4y squared minus 4y. We always begin with greatest common factor. Well, what's our GCF? Well, our GCF for numerator looks like 4y. So we have a numerator of 4y, and our remaining factor, when we divide 4y squared by 4y, we get y. And negative 4y divided by 4y is minus 1. And so these are our factors. For our denominator, our GCF looks like 4. So we will have 4 parenthesis y squared, because 4y squared divided by 4 is y squared. Negative 12y divided by 4 is minus 3y, and 8 divided by 4 is plus 2. But now we have to say, can we factor any more? And the answer is yes. So now we have 4, two numbers that multiply with y squared is just y and y. Two numbers that multiply 2 and add to negative 3 will be negative 2 and negative 1. So our fraction now looks like this. 4y times y minus 1 over 4 times y minus 2 times y minus 1. And so now we want to play the matching game in this case. Now we have everything factored. We're going to match factors of numerator and see if they divide out with any factors of the denominator. So for example, look at the numerator. Our first number is 4. Our any numbers denominator divide out with the 4 numerator. And we see, yes, the 4 and the 4's divide out to 1 and 1. Are there any y's alone in denominator to match with numerator? And you're so tempted to divide out with the y minus 2 and the y minus 1, but they're not factors in this case. The y in those denominators are not by themselves. They are attached to a plus or a minus 2 and a minus 1. So they're not the same number. So you have to be very tricky about that. So we see in this case, no, we cannot divide out the y with anything in denominator because the y minus 2 and y are not the same number. Like 5 and 5 minus 2 do not divide out. So no. But the y minus 1 matches up with the y minus 1, and these divide out. Now this leaves us with the answer of 1 times y times 1, or y, and 1 times y minus 2 times 1 is y minus 2. And this is our final answer. There is a temptation to divide out the y's, but they don't match up. Okay? Let's try out the question number 5. So, greatest common factor for the numerator looks like 6. So we're going to get, in this case, 6 times 2 minus x. And now for denominator, no GCF, but we have a difference to perfect squares. X squared minus 4, because they're both perfect squares. Square root of x squared is x. Square root of 4 is 2. Plus and minus. So we factored. And yes, this is a very important part of our simplifying. We see in this case that the 2 minus x and x minus 2, they're very, very similar, but not exactly the same. Well, here's the thing. Sometimes when a numerator and denominator are additive inverses of each other, their fraction simplifies to -1. So for example, you have a minus b divided by b minus a. You get -1. And some students go, I don't understand that. Well, if you have, in this case, numbers like 7 minus 2 over now 2 minus 7, additive inverse in this case, so we get 5 over -5, which is -1. If we pick different numbers like 8 minus 4 over 4 minus 8, we get 4 over -4. That's equal to -1. So you notice the same numbers kind of reversed, subtracting each other. So this allows us to see in this case that if we see the same numbers just kind of switched but they're subtracting each other, additive inverses, like you multiply the whole thing by -1 to get the same thing, yeah, it simplifies -1. And so we see here the 2 minus x, x minus 2, these divide out, and we get 1 and -1. So we finally get an answer of -1 times 6, or -6, over x plus 2. And this is our final answer. Okay? Last thing we'll talk about in this case is very important for simplifying rational expressions, is going to be the following, where we see in this case, for what value does 4x plus 8 have no meaning, or 4x plus 8 over x squared minus 2x minus 8. So we want to factor, but we want to factor our denominator. So in this case, x and x, two numbers that multiply -8 and add to -2 are -4 and +2. But what does this mean? Well, very important. When the denominator fraction is equal to 0, then the fraction is undefined. So undefined, that means to have no value. So we're talking about, in this case, we will set our denominator equal 0, so x minus 4 equals 0, x equals 4, x plus 2 equals 0, x equals -2. So when x equals 4 or -2, the expression has no value. Okay? And this will end our lesson, ladies and gentlemen. I hope it was helpful, and I look forward to seeing you in our next lesson on rational expressions. I hope you enjoyed this lesson on simplifying rational expressions. And please make sure to like and subscribe to our channel and leave any comments in the comment section below. Take care, everybody. Have a great time, and I'll see you in the next video.